In this lesson, we are going to talk about the unit circle. So now that you are in grade 12 pre-cal, you should be somewhat familiar with the unit circle from grade 11, but I'm still going to go over sort of the basic idea of what the unit circle is. Essentially, a unit circle is a circle with a radius of 1, and its center is at the origin. So because this circle has a radius of 1, we can form triangles within it. And those triangles will all have a hypotenuse of length 1. So what we can derive from that is that x squared plus y squared, or if we look at this coordinate as a coordinate x, y on this grid, okay, but hitting the unit circle, it's a point x, y, we've got an x value and a y value here, which are distances or lengths for the sides of these triangles, where the radius is 1. So from that, we can essentially derive an equation for the unit circle. And that equation is that x squared plus y squared must always equal 1. And you can use that equation to determine whether points will be on a unit circle or whether a circle is a unit circle. So for example, in example 1, it says find the equation of the circle of radius 5 with a center at the origin. Is this a unit circle? So in this case, x squared plus y squared would be equal to 5 squared, since the radius is 5, and x squared plus y squared would equal 25. This is not on the unit circle, since the radius squared does not equal 1. If we look at example 2, it asks if the point -3/5 y is a point on the unit circle, find the value of y. So from here, we have an x value and an unknown y value, but we know the equation of the unit circle is x squared plus y squared equals 1. So I can plug in my known value of 1 and my known value for x, and then I can solve for y. So here I've squared -3/5 to get 9/25, and then on the left side here I just changed 1 so that it would have a common denominator with this 9/25. That way, when I go through the algebra, I can subtract 9/25, which would be equal to y squared, and then square root both sides. So the point -3/5 with a y value of either 4/5 or -4/5 would be on the unit circle. Now, more importantly than that, you'll see on the next page everybody's favorite, and that is the unit circle itself. So in grade 11, we learned about the degree measurements along this unit circle, and also all of these coordinates, so all of these x, y coordinates. We're not going to go through those again in terms of where these come from. If you're not sure or you don't remember where all of these coordinates come from, you can either look back at your grade 11 stuff, because I know you all kept it. If not, if you do a quick search about coordinates on the unit circle on YouTube, Google, you'll find an infinite number of websites, videos, etc. that explain where those coordinates come from. So in grade 11, we did all of these coordinates and used them to solve, and we also used degree measures for all of these angles and used those in various problems. In grade 12, the new component to the unit circle is the radian measures. So that is the part that's new between grade 11 and grade 12. So I'm going to take a little bit of time, and in the first couple of lessons in this unit, we already started to work with radian measures, so you should be a little bit familiar, but I'm just going to show you how we derive all of these radian measures on this unit circle. To do that, I'm just going to start with a blank circle here. So I've got a blank circle, and what we know so far in terms of degrees is that this is 0 degrees. Up here is 90 degrees. Here is 180. Here is 270. And then this is also 360. Those are all measures that we know. Now, hopefully from grade 11, you will remember that we also subdivided each of these quadrants into 3 other angles, 30, 45, and 60. It's not exactly divided into thirds, but we had 3 measures here. Now, when we're working with radian measures, you should remember that 360 degrees is equivalent to 2 pi, which means halfway around the unit circle is equal to pi. In our first lessons, we talked about that. Now, if we take pi and we divide it by 2, or 180 and divide it by 2, we get this measure of pi over 2, or pi by 2. Similarly, if we add another 90 degrees, or we take 2 pi and divide it by 3/4, multiply by 3/4, okay, to get 3/4 of 2 pi, here, this is 3 pi over 2. Now, I'm going to focus on the upper half of this circle for a minute. I'm just going to look up here. If I take this half circle, and I know that the entire thing is equal to pi, I can then split up this circle into quarters, into thirds, and into sixths. And I'm going to start by splitting it into quarters. So to split this into quarters, I've already got it split in half. If I take each of those halves and split them into quarters, here I have 1 pi by 4, which we will not generally write the 1 there, but 1 over 4. This would be 2 out of 4 if I went all the way to there, which reduces to 1/2. This would be 3 pi over 4, and this would be 4 pi over 4, which again, these would cancel out to leave us with pi. So that's how I measure in quarters. So on my unit circle, I have 0, pi by 4, pi by 2, 3 pi by 4, and pi. Now, I can extend this and continue around the circle. If I add one more quarter, it's a quarter of a half of the circle, then this was 4 pi over 4. Now I have 5 pi over 4. Down here, I would have 6 pi over 4, because I'm adding another segment. Here, I could do it again and add another segment, and I would have 7 pi by 4. And then finally, I would have 8 pi by 4, which is equivalent to 2 pi. So with all of those, sorry, my drawing is a little bit big for the frame. All of these are just fractions. 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8. I've divided each half into quarters. Ultimately here, I've taken the whole unit circle and divided it into eighths. Now, I'm going to take a new unit circle. So that's quarters. Now these pieces are all exactly in the middle of each section. So this is 45 degrees, this was 90, this is 135. Okay, these degree measures and radian measures are exactly in the middle. Okay, and I could keep going and have, this is a degree of 225, 270, and 315. Essentially, these are all 45 degrees apart, or 1 pi by 4 apart. Now, I'm going to do something similar. I have another blank one, so we have a blank slate to work with. Again, we know that this is 0, 90, 180, 270, and 360. If I then take, again, my half, so this is going to be pi, this is 2 pi. If I take my half circle and I now divided this into sixths, because if you remember when we were working with our unit circle, we had 0, 30, 60, 90, 120, 150. That one lap around we were counting by 45s essentially in degrees, and then in these other segments we were going up by 30 degrees. Now we're going to do something similar here. Instead of going up by 30 degrees, we're going to go up by the equivalent of that in radians, which is sixths. So I'm going to take each segment here, each quadrant, and divide it into thirds. And then again over here. Oops. And when I do that, essentially what I end up with, oh my, is, let's pretend that's a straight line, is that I've taken this entire half circle and divided it into 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And again, those fractions, a few of them can be reduced. So 1/6 can't be reduced, but this is equivalent to 1/3. 3/6 is equivalent to pi by 2, which we already know because we know 90 degrees is equal to pi by 2. 4 pi by 6 is equivalent to 2 pi by 3. 5/6 can't be reduced, and then 6/6 is equal to pi. And I can keep going, so I could divide down here again into thirds, and I could keep going. This was 6/6, this would be 7/6, this would be 8/6, which is the same as 4/3. This would be 9/6, which is the same as 3/2, 10/6, which is 5/3, and 11 pi over 6, which doesn't reduce, and then 12 pi over 6, which is equal to 2 pi. So I'm just counting by thirds and sixths and reducing the fractions. Now you'll also notice that when I count by thirds, here I have 1/3 that's there, 2/3 that's there. So this is going up by 60-degree increments, or thirds of the half circle. And then same here, your thirds are here and here, and the others are sixths. Now if I take these two drawings that I just showed you, so the one where I've got fourths and the one where I have thirds and sixths, and I put them together, you'll see what happens is in these radian measures, we again have 0, then we get pi over 6, pi over 4, pi over 3, and we've got pi over 2. And then we take the reduced fractions. So remember, we've got thirds here, 2 pi over 3, 3 pi over 4 for our quarters, 5 pi over 6, and then pi. And we continue around the circle with those radian measures, always reducing the fraction as much as we can. So when it comes to actually memorizing the unit circle, I'm hoping that you remember how when we were doing the degree measures, we were counting by 30s or 60s or 45. So in the same sense, we're actually working with these fractional pieces, sixths, quarters, and thirds, but reducing their fractions. So you don't have to worry about just memorizing. You can actually, as long as you remember that you've got 6, 4, and 3, you can then work around the circle and just reduce your fractions instead of trying to individually memorize. sorry about that, individually memorize each value. Please also take some time to review these coordinates. So if you recall, these are x, y coordinates, and they represent the coordinates of these points when we form a triangle, and then we are going to form triangles, I should say, inside our unit circle, where this is the x value, root 3 over 2, and this is the y value, 1/2. And the radius is 1, and the angle here would be 30. And that's how we form all of these triangles. That's what these angles represent, is the angle between these terminal lines and this 0. And we're going to form all these triangles. And these coordinates represent the x and y values, or the distances or lengths of the sides of the triangles. So please take some time to review those coordinates because you will need to know them, and you will have to know this unit circle to memory. So you won't have one to refer to. So it's really important to go back, refresh your memory about the patterns of how to derive all of these points, and make sure that you're feeling really comfortable with how to use the unit circle.